Just getting myself on all the social networks. I'm alive, by the way. Okay. So tell me things. Great. Okay. Okay. That's a bunch of social network stuff. I should probably increase the size of some stuff here so people can actually view these. And then I'm gonna start. See here. That might be a little big. That's a bit big. There. It should be more viewable, but not be entirely oversized. Okay, so I'm going to work on the Lisp, the namespace and modules features of it for something that we're working on. So the first thing I need to do is actually make the build script that builds the code for me and makes me a Visual Studio project. So we have our own little utility to do that. So that's generated the CMake file for the Lisp. And now I can go into make a build folder. And in here, I can now actually run CMake. The CMake files are in the parent directory. And then, because I'm on a 64-bit system, I'm not sure if we fixed this bug yet, I'm going to set the platform to be 64-bit. And if I didn't screw anything up, this should actually generate the CMake file. I just realized that I haven't double-checked that I have the latest version of all this stuff. So I'm going to do that now, and then I'm going to update these scripts really quick. I don't have my authentication, because I just turned on my computer. So I'm going to go do that on a separate browser so you can't see where I keep my key files. One moment. Okay. So now I'm going to actually get the latest version of the source code. Use the fetch and rebase strategy. I'm going to make sure that I have all the different dependencies up to date really quick here. So the dependencies for the Lisp right now are just our internal utility, our internal utilities, and our type system, which there apparently are changes in here. Okay, they're minor. So our type system is a dynamic type system that we add to C++ to add some features like reflection and stuff to our objects. So now I can rebuild this really quick. And now I can open the Visual Studio file. Actually, I need to actually regenerate both of the files. That still didn't do it. I need to regenerate the build files in the other ones. So this is just, I decided to start by setting up this environment, so hopefully this isn't too boring. I have to go up one. Okay. Now that I've rebuilt all the CMake files for those projects, we haven't finished. I mean, that's our own build utility, so we haven't finished adding everything to it yet. Now I can go into the build for Lisp build. And if I go, yep, okay, so these are now separate folders. That's the correct way for this to be organized. Great. I'm not sure what to do with the text size of the editor but we'll see. So I'm going to try to build the solution. Meanwhile, while that's going, let's see if I can actually make this bigger. I can't do it that way. I don't think I can just like set the, yeah. Is there another way to set the size of the text? I'll look for that later. So, and then we're going to set the default entry point. So we'll have to wait till this build is done. Okay, set the entry point. So now if I run this, we should get my current version of the Lisp, which I will make these bigger too, because this is a default console and not a PowerShell console. Okay, there we go. So at the moment we have the basics. I can add two numbers. I can ask if so I can find out whether something is true or not. So if I did like don't have a lot of things to actually check here, but if I did, that's also going to be true. Okay, so anyways, but more interesting is that it has things like this. Thought it had that. Definitely has addition, but point is we need to add namespacing, add modules to this so that we can import these things in better ways. If you actually look at a function like truth, it'll tell you what kind of thing it is, right? So that's the C++ class that's actually implementing it, and the type ID and the actual pointer. Um, there's also a type system. So there's, for example, bool is a type. Pretty sure int is a type. Yeah. String is a type. Yeah. So this is the type system's verbose printout of saying that's a type. Here's how I'm going to format it, and this is the format of it. And so I can actually do things like, so there's a subtype system. So this subtype, right? So if I call subtype on, say, int and any, int is a subtype of any, but anything is not a subtype of an integer. And then there are things like unions, int, string. So union would say it could be an int or a string. So if there's an any, a union of an int or a string fits in an any, right? But then, so if I have an int here, it doesn't fit. But if I put an int on the other side, an int is a subtype of a union of an int and a string. So we have a typing system in there already, for the most part. Before we can add more code, like addition and multiplication and all those other things, we need a way to actually put them into like modules and namespaces so that we have separation and we're not just stuffing everything into one giant scope. And so that's what I'm going to be adding today. For some reason, I'm getting a viewing error. Let me mess with my broadcasting software really quick. Because it's saying that I am transmitting too much stuff. I'm not sure what it's having a problem with. Oh. We'll see if that fixes it. Anyways. Great. So the first thing is we actually need to look at what we already have in here. So we have a scope. It's a very simple class, and this has sort of been what we've been using as a pseudo namespace for the time being. We have an environment, which is where we have the type system helpers, which need to be moved out of here. And this is where we read code, we log things, eval things. I thought that the scope, yes, so the scope takes an environment, and it can have a parent scope at the moment. What I want to do is add a namespace and a module objects. The difference between them is that a module is some sort of source code that comes from somewhere, like from a database or a file, whereas a namespace is a bunch of names that are in a shared space, so that a module can share a namespace with a bunch of other modules. And modules will have their own scope that's kind of like a private scope inside of them, so that things don't have to necessarily be added to a namespace by the end of the module. The reason for doing it this way is because we're using a feature called multi-methods, and multi-methods are pretty resistant to naming conflicts. because instead of there being a naming conflict, they can be merged together. And so if one module says, I create a new type, and I want to do this method to it, and this method is called foo, and then some other module somewhere else in some other project in the same namespace says, I'm creating this other type, and I want to do this method to it called foo, when those both get added to the same namespace, it can merge them together and use the types as dispatch, and there shouldn't be a conflict in that example. Where you can get into conflicts is when you start writing like higher level metacode, where you're saying any type that looks like this, use this method. And then somewhere else, somebody else says any type that looks like this, use this method, and then those might start to conflict. Then you're going to have to use some sort of resolution rules when you import the modules, and we'll have the features to allow for that. For now, the primary strategy is going to be just give them different names so they're not actually in conflict. So that is what I'm going to work on. So the first thing we have to do is actually add some files to our source code. Thank you. Snacks.
Snake delivery. Did my computer turn off again?
I thought you turned it off when you left.
Put it asleep.
Maybe it's sleeping incorrectly?
Very sleepy?
Yeah, very sleepy computer. Anyways, I'm gonna add a new module, class. For now, the module is just gonna have the one the module implementation is gonna do a bunch of dual duty, but eventually these will be separate objects, like a file module, a console module. But for now, I'm just gonna put them both in the same module class. And then we're gonna need a namespace. And then I think scope needs to be turned into some sort of aspect, which is a feature of our current type system. It's an aspect. It's like an interface, effectively, but we can do magical things like forward it from separate classes or forward a variable. So you can do like composition, and then the object will still respond to like requests like, do you implement this thing? Without having to put all of the things that you implement as dependencies and using multiple inheritance. So it's one of the tricks we can do with aspects. So those are my new things. I'm going to come back here, say, whoop. So I can just from this directory reissue the. So there we go. So there's our files now. Now we're going to add them to the header. This is not the right. This is the types system. That's not the header I was looking for. Here's the header I'm looking for. So I think they're going to go here with scope. I think I'm going to put them after this. Module, and I think namespace is going to go here. We'll see. I think actually these should go before environment, after scope. Okay. And so now if we look at this, I'm just going to do some copy pasta, copy this, because I already have formatted the way I want. Module. So this is our macro for our object system. So the module is going to need an environment. I'm tempted to say it's not going to need a parent scope, because I want modules to be constructible in a different way. So a module takes the environment, and then I think we're going to give it a couple different constructors. So we're going to do a string path. So this is the path of the file to open. So this will make a module as a file. I think we'll make it a static method, some way of cheating that will initialize this into a So it needs a return type. So instance is our shared pointer class that we're using here. I will zoom in because it's probably really tiny. There. Sorry about that. So module is our shared pointer style class that also provides a bunch of helper methods for our class. So this will be a cheaty method to make a live module for like the console and stuff. Doesn't have a parent scope. It is going to have these lookup and define functions. Is going to have access to the environment. Is going to have access to the path of the module. Okay then. So that looks pretty much like a scope, which was sort of my intention, because it's going to share an interface with scope in the near future. And so the namespace, this is the more interesting one, because this one is going to have a parent environment, does not have a file path. So the namespaces are going to know where it's getting its definitions from. So this map is now out of date. We need a custom struct to put in there. Something like entry, I guess, for now, since this is the namespaces entry. It's not much that I can do to change the description of that. I'm going to change this to lookup, though, in all of them, because I don't like calling it a namespace, because we're not using namespace to mean something else. So the difference with this one is we're going to have this. And this is going to be, let's call it actual. So that's the actual value. And then we're going to have the module we got it from. Okay, so now we have to change our constructors.
Yep.
We don't need this helper method anymore.
ABB.
So we need access to the environment. Won't need access to the file path. So this is going to be our scope, is what I'm thinking. These two functions, a way to look up and a way to define. I think I'm going to change the name of this to define, though. So I have to change that everywhere. I'm just looking at some social media stuff. One moment, please. Social media stuff related to this broadcast. Anyways. I'm just seeing people liked and shared my thing. I don't know if any of you are actually real there.
That I was gonna stay home in Bellingham because I was sad that my wife left me, but then I came down to see my dying grandmother on Christmas.
1 second. So, okay, great. Sorry for the interruption. I am new to this thing. Feel free to say things in the live chat if you have any comments on my programming ability. So now we actually have to go implement the code for these. Oh, I was going to do the scope one as well. So we will go do scope. So scope is an interface. So it looks a bit different.
But I mean, it's winter.
So I don't just have to declare the scope name. I now need to define a bunch of other variables, like the name of it and what sort of manager it uses. There are some pretty standard ones, thankfully. So if I go to the types namespace, factory aspect manager is the common one, which basically says if there's a this basically is usable with a lot of stuff. And what this allows is that it basically, whenever there needs to find a new thing, the provider for this aspect is able to just do whatever it needs to do because it's a factory. Some of the other ones are more explicit in what you can and can't do with them. But these, like the casting aspect factory ones and the forwarding aspect factory ones, are implementations of the factory manager for different types. But so we want a factory aspect manager. And we're going to call this, I think it's Lisp. So I'm going to look at some of the other ones to remind myself really quick of what sort of naming scheme I used. So yeah, just a Lisp.scope. It's the name of this interface. And then there's probably a difference in how we're... Okay, it looks good. This may not need to be explicit. So now the only problem is that we're not inheriting from the right thing because we're no longer an object. We are an aspect. Now that's a provider, which is a different kind of thing. It's not a virtual dependency. So that should resolve itself in a minute. So aspects don't usually have any private sections. Yeah, so that's all good now. Don't need a constructor. The requirement for a virtual destructor is part of aspect. So now we can have our methods here. So we're going to make these abstract virtual methods. So this is our aspect. The only thing we have to do now is go to a code file somewhere and do the initialize all the static variables that I use in the macro. Just pretty straightforward. Done. Okay. I'm gonna go on a social media thing again really quick here. Sorry, just trying to get more viewers other than the one viewer that I have right now, who I don't know is actually real or not.
That's you watching it.
That's what I think. I think it's me watching it. But you gotta get in the thing.
Gotta get that. You gotta start somewhere.
So Okay, now look at requirements for watch people code.
What?
There's a subreddit called Watch People Code that you can post on, and they'll automatically.
You can post one time, right?
You can post more than once. You can post like once a day.
Post when you go live?
You post when you go live, yeah.
Wow, that would have been helpful. Because I got like 400 views the first day when I did that, and I thought I could only do it once.
I'm sorry if I made that mistake. Okay, well, I may just throw myself to the wolves, but put myself on watchpeoplecode.com. See how that goes. Yeah. Okie dokie then. I'm just gonna give that a minute. Okay, so we have our aspect, our interface basically. I'm going to go add that to the classes now. So public, there's a little helper template. That does a bunch of the bookkeeping for us, so we don't have to. Namespace, module, and scope. Great. And now when scope takes a parent, it's going to be an S scope. Because it's going to say this is who to look up in. If it does not here. This class is going to go away at some point and be replaced with a thing like a code block with like a let and variables in it, which will implement S scope as well. But that's not for today. Oh, now we have to go implement the code for namespace and module. And I need to fix up the code for scope because I changed the interface. And these need to actually use the interface as well. So we want to put overrides on here. And I have to make them virtual. Great. Now I can go fix up the scope code really quick. Change the name of this to be define. And this to lookup. And change all the variables that we changed. Great. And then here, we're going to put the usage of the interface. So this is sort of our literate expression system for our type system, so that I can describe that scope is using the scope interface, so that you can get there by casting. And this is sort of the jumping off point for like forwarding stuff and all that fun things. So that's the scope class done. I'm going to just use the code for the scope class when we go to implement namespace and module. This one's module. So this takes a string as a file path. This doesn't have a parent, but it does have a file path. I've been doing too much C# lately. I forgot to put the namespace on there. And we'll use this same code for now. Although this is not even going to the parent right now, which is something else that needs to be fixed. But luckily, there should only the scopes are going to have parents, because these are going to be code blocks later, so you would want to go through each of the parent code blocks, and then you would look at the module, and then you would look at the namespace. But we'll get there. This is the namespace. Oh, I should also change this. I know what file we're in. Great. Namespace. I've been thinking about putting the name of the namespace in the constructor for the namespace, so the namespace knows what its name is, but that's probably not actually necessary. We'll see. Okay. looks like I screwed up. Module undeclared identifier. So, did we put these in the wrong order? We did. That's gonna get tricky, but should be fine. So, I'm trying to think of a good way for the namespace to know what module these things come from, because this define function is part of an interface. And I think it should just be as simple as saying what module we're currently loading into the namespace, because I don't think I was planning on making namespaces to be thread safe. I would expect that you would load all the modules for your namespace, and the result could be threaded code. But the namespace itself was not going to be multi-threaded for a lot of reasons. So I think we can just do a stateful function along the lines of graph. So we'll copy our export macro, and we'll say something like set current module. And then I think we'll have this return the previous module as well, so we can use it as sort of a swap it back to the old one when you're done. Set current module. And so then we can use that when we create the entries to know which module we're in. So we'll add that to the namespace code. So environment is just everything. That's the root environment. So without that, we can't do anything. So that's why a lot of classes will just have this environment on it. I'm not sure of a better way to fix that at the moment, because if you want to have more than one interpreter, we need to do this, because each environment would be its own interpreter, its own complete memory section of the Lisp. So I'm not sure of a way to fix that at the moment to reduce that code, but we'll see. So set current module, and then we need a variable for it. And then just make sure we set that to a null pointer. Begin with. Thought I fixed that, but whatever. So that's a null pointer as far as the instances are concerned. And then here we could do save the current module to an auto, set the current module. What I'd like to be able to do is guarantee the swap function is ran here and then just return module, because that would be faster, but I don't think it's a big deal at the moment. It's not like that function's going to get called a lot. So here we have a problem, because this is not the right kind of type. We actually want the actual out of there. And here we have to create, here we can do current module. Great. Let's see what we got. So it looks like that's building. Nope. Spoke a little too soon. So this is the first thing. We'll come back to this, because I actually want to make this right here a module. Yeah. I'm not sure how to do the file paths for things that are special, especially because we're on Windows. Maybe if I do think using the drive syntax is probably wrong, but on the other hand, I do want to use like a protocol syntax to say this file is not a file like this, but instead it's an internal, it's a special one. Maybe we could do like that. So, sure. So we'll come back to this. What I'm more interested in is this. So I've misconfigured a scope function here, module.h. Use scope is what I should have said by casting. I think I just had a brain fart there when I was writing the code. Yeah, that's scope correctly. So I got that one right, and then I copy-pasted them wrong. Okay, great. So that's that error. The other one's going to be everywhere that I use def instead of define, which is going to be primarily in that big one, into that one where I'm setting up, yeah, this one where I'm setting up the global module. So I think I can just do a control find replace here. So find what in the current document. We're looking for ret def paren replace with ret define. (23) occurrences replace. Okay. So that should fix that one. Okay, so now for the tricky ones. So this one, this is the define special instance. So this is actually for defining things. So that should work, hopefully. So this is the object. Scope. Where are we getting scope from? Yeah, so you get its scope inside this. Yeah, the scope is the first thing that's always passed to this. It should really probably be an S scope. Let's see if the code works if I just change that to an S scope. We're going to have to go change the special form as well, though, because these are all expecting scopes instead of S scopes. That's okay, though. Change that one. That's probably going to mess with some stuff, though. This eval, I suspect, is from something that this implements. We'll see. So this takes an S scope. So environment is now the thing I'm missing access to here. I don't know what these are. So yeah, we need to fix up this library really quick. This should really return a module. Better. So there are different kinds of functions that are each objects in our system, and they have different calling mechanics depending on when they're evaluated and how they're evaluated. So this is a built-in function. So that environment class really needs to be added on to the list of virtual functions in scope, which is fair, I guess. Scopes are going to probably be the I mean, they're the way that you access all the names and all the other code. So I think having the environment be on them is not a big deal. But I'm wary of putting it on too many other things. Like I don't want to put it on all the function calls and stuff. But I think this should be the class that has it at least. So whatever. I don't know what his problem is there. I think that's just it being a bad. Great. Now I just gotta go make all those other ones overrides. Namespace. Oh, forgot the const. Great. So I should just copy this now to the other ones. Let's make sure that not, yeah. Boop. And scope. Great. What do we got? Nope, didn't change the calls themselves. Code binds. We also did special form, I think. Yeah. I would bet the multi-method, which is actually one of the more hideous looking function calls, because it's the one that actually does the cool stuff. Yep, also takes a scope. So now I have to change the dispatches. The dispatches don't take a scope. That's probably for the best. That's what I'm looking for. Oh, but they should. They're going to have to take a scope. So attach environment instance. Oh, they do take a scope. It's hidden inside this instance here. So we don't have a class for callables yet, don't we? We have p-subroutine, right? Yeah, we do. And this should really be a p-subroutine. We'll get there. Not a big deal at the moment. Now this global is not a module, but it should be. Make that take an S scope. So macros are current only. Last, a holdout. Macro scopes are a little interesting because they're not runtime, but they more or less are the same. I don't know if macros even really should have scopes, but they probably should. Just not sure what's going to be in them because we can't put the live results. Well, we can. We can put the functions in there as long as you do them in order. We'll have to come back to that. So what's going wrong with this call here? For function. So this is an in source code function. You'll know that most of these are just different ways of creating code. There's some link errors there, but I'm assuming that's because it didn't finish building. Okay. These are some linked errors. Link errors. Special form cannot convert argument 1 from make library globals to special form feval. Is that a link error or a compile error? That looks like a compile error. It is a compile error. Well, that's why we're getting link errors. Here it is. What's wrong with this function? Not have the right arguments. This scope, it probably doesn't have this, is the problem here. It's probably another one that I missed. Cannot convert argument 1 from. So, cannot convert argument 1 from make globals to, yes, fcall. Okay, so it can't convert the lambda to the function signature that I expected. So it's pointing here. So this is our function signature of our lambda. If I go to built-in function, this is the function signature it expects. Right, returning an instance scope, standard vector of instances, const ref. Which incidentally is the same as this one here. Let's see. Yeah, fcall. This is an fcall. We are returning an instance. That's what we're doing here. Oh, instance scope. Yeah, the correct name for scope. Okay, one down. I'm assuming the next two are pretty similar. Yep, scope. What's the next one? That's the wrong link. Scope. Great. It's just some bad copy pasta. Gave us linking errors for linking all the copy pasta together. And we have a good build. Oh. So now we can add two numbers together. Yay! So our code's working. We do actually have like a define foo5. If it was in the scope, maybe it's, yeah, okay, I called it def, which I am now disagreeing with, but whatever. Def foo5, foo, I get 5. There is a function as well, so def bar lambda x. Make sure I get all the names here right. Yeah, lambda. We have conditionals. I don't like this name. I change that to define next time it gets compiled. Did I finish the function description? Multi-method. No, we'll just use lambda. It is a function. So lambda add foo2. Right, so that's bar. So bar is a function. Bar is a function. So then if I do a def foo teen, and then I run bar, it's 20 because I'm adding 2 to that. So I got variables, yo. One thing to be aware of is that that's probably not correct behavior, because really what we want is this lambda to bind to the foo when I wrote the lambda. So then the foo would be 5. And then what I should have to do is do something like a def foo var 5. And that'll create a variable that I can set and edit and things like that. But we'll come back to that. Okay, great. And so we're now using a module for our globals. That was the first step. Think about the next step here. Next step is we need to add the namespace and set what module we're generating. Yeah. Set what module we're importing into the namespace at the time. Let's go to the load code, because we have some code for loading new modules here. So I mean, this puts it into a string for us, so we can load text files for testing purposes. And this actually evals it. So really we want all this to be evaled inside of a module. So I have this nice little formatting library that I'm going to use here because I'm lazy. There. So that'll create the new module. That's the scope we're going to use to eval all these things. So when we read that, it should all get put in that module. Now the thing is about Lisp is that when you read modules, they place all of their code in whatever scope, whatever namespace you were in when you evaluated the module. So that means you can put all the variables from a module into the namespace. So now that we have our module class, I could use it to eval this code from this file. So, and I have a current working directory, so I know where I am. So let's go ahead and write some code and stick it in the module. So that's where I expect it to be. Now I can put some code there, load it into a module. So we were in the build directory, so this is where we were. We already have a path system, so we should be able to go up, go to scripts or something, source. I have a feeling, test, there we go, this is what I'm looking for. So we can make a new test file, put it in here, just something with some defines in it for our module, having it. So now I should be able to do so eval the file from where we are, which is up to the Lisp directory, and tests module.call. Okay, well, let's see if that's what I expected. That is what I expected. I actually want to do is return the module. So let's grab this. Okay. Copy the long string. Let's try that again. Okay. So check that we're still in the right spot. We are. Let's try evaluating that again. Okay, so we actually got the module this time, which is what I actually expected this time. So now we need to put in the little chunk of code so that we can access the functions off of it. So then we'll be able to access stuff directly out of the module. So let's add a lookup method. It's not a special form, it's just going to be a built-in. So scope, arguments. Yeah. This is going to be a multi-method in the future, right? Yeah, so it is a multi-method. But for now, we're going to add an implementation of it for the module so that we can look up functions on it. So the first argument is going to be the module. So the actual, we're just going to call it scope because the lookup method's actually on the scope interface. So the first argument will be a scope, and then the second argument will be the string that we're looking for. So this will be the actual name to look up. So now we can do, it should just be lookup. Oh, because it's, so this is the lookup scope. It's not the actual scope of the function that we're running. There we go. Lookup scope. There we go. Got confused there. There's our lookup function. Lookup name. So this will work not just for the modules, but for the namespaces and for the generated scopes for code. So this is actually super nice. And I'm probably going to want to change the name of this at some point, but for now, I just want to make sure this is working. Okay, so I screwed something up here. I need to dereference this because this instance is like a pointer. So I need to dereference the pointer to the string. There we go. No longer have my thing, so I have to rewrite that. So we want to eval the file, test module.call. There, so there's our module. So we'll put it in a variable. Actually, before we do that, we should actually make sure there's actually something in there that's interesting. Which there's not. Let's just do a define foo lambda. Yeah, define foo 15. Define bar as some text. Great. I thought I changed. Did I not change that? I did. Pretty sure I did. Let's try this again. Okay, it is a special form. Know where we are. Maybe I misspelled define. Never know. Define. So test module. Oh, I know what's wrong. That error is actually from here. Okay, so the module's not getting the global scope is now our problem. That's not good. Okay, so before we can actually test this, we need to finish namespaces. Because the console's a module, and what we're trying to say here is load this module into the current namespace, right? And then the console module can access that namespace and do things to it as well. Yeah, because define is a global, but right now I'm not it's not in the namespace for. I mean, all namespace should have the all namespaces should have the globals in it. I mean, that's another problem, right? Like, just because this is a brand new module shouldn't mean that the scope for it is empty. But I want to be able to initialize modules multiple times as part of the problem here. Well, we can reevaluate the code. We can in the future deal with improving that. I don't want to get into like premature optimization too much here. So I think we need to do namespaces now, so that when you import a module, it can access the other modules in that namespace. And when you construct a namespace, it's going to add the globals module to it. So yeah, okay, that makes sense. Yeah. So we make this module. It needs to know what namespace it's in, I think, is the first thing. That's going to be one of its arguments. I don't see a way around that. Yeah. Hmm. What I'd ideally like to have is the namespaces would have a list of the modules that they've loaded and the list of symbols that they loaded from each module. So when you're in a namespace, you say, where's this symbol come from? It can tell you what module it's coming from or what modules it's coming from. In the case of, for example, multi-methods will have multiple functions attached to them that may come from multiple modules. And so you'll be able to see this is where the original module is and these are where all the other modules are. I'm also thinking that maybe it should be part of the define structure, like metadata about the define. Because I want, in the future, I'm planning on, for example, when the scopes become like code blocks for a scope and you're declaring a variable, it'd be nice to be able to declare metadata about that, like where on the stack it goes or things, stuff like that. So I think the current structure of the defines is part of the problem, where it's define a string and then the value for that string. I think it needs to be define a string, the value for that string, and a collection of metadata for that string. For that, yeah, for that value. And then one of those metadatas can be the module where it was defined. I think that's definitely the better way to do that. And then we can do thread local current module features. And then it would be simpler to make the namespace thread safe. Simpler, not perfect. Yeah, so we'll get rid of this. Get rid of this. Don't need either of those. Delete this code. Get rid of this. Change this back to what it was. Now, now the problem is we actually need to go make an entry class for that. We can put doc strings on it. We can put source code locations. We can put the modules. We can put other sort of binding information on it. Though for things like dynamic variables, I really think that those should be classes. I think that the define should be static, more or less. Not trying to do that part, but may need to implement some structural sharing data structures before we get to that point. But I think it's time for a define structure object. It's not the defines in the Lisp, those are the defines for C++. Not what I was looking for. So I was just trying to think about the scope of this define structure. One of the other things we have to deal with is functions have arguments that are effectively defined, except they have metadata about, like, you can't change them because of how they were passed into the function. But you could think of them as actual variables, I guess. Do I want that? Do I really want to just say binding here instead of like defining? Like, is the difference between an argument variable, a locally scoped variable, and a modularly scoped variable, are those similar enough that I can just put them all in the same thing? And I think they are. So I'm going to call it binding. And then a CPP file. And then some build system touch-ups. Okay, so this define function is going to change. So now it's going to be an instance of a binding. We don't have any special lookup rules yet. But at some point, these lookups may get replaced with data structure that be structurally shared, or maybe does special binding lookup rules, or I don't know. But yes, I'm now happier with this. So let's go add that to our list of things. And put it here. I think it's fundamental enough that it goes there. We may want to start organizing this pretty soon. Sure. Another thing to take into account. We'll deal with that later. Okay. What is a binding? It's definitely got the metadata associated with it. I don't think that the define should control the access controls. I think that should be the object in the binding itself. Like, if you have a variable, you can decide whether it's thread local or if it's like locked, or if it's just not. If it's how it's scoped, where it lives, things like that. That should all be decided. Where it lives should be decided by the define. But the contents of it, the behavior of the variable, should be part of the define itself. And you can do macros like defvar, things like that. So like defvar will probably be a pretty common one. Being able to say, define some variable that like I can set the value of and stuff. Whereas a define is saying, set this name. And then we probably want to, when you go to look up that name, you want to know what that name named. But you don't want people to be able to change it on you. I think is my thing, because one of the problems is if you write a function for a multi-method and we do our type-based sort of optimization of that function, you shouldn't be able to replace that function using a define. You should have to go through, yeah, because if you added a multi-method to that, you would be modifying the multi-method, and the multi-method would then be able to notify anybody who had used it that its code had changed, and that would allow it to be recompiled. But if you change the definition of the multi-method to some different multi-method, you would lose all of that state, all of those features. So I think using the single define sort of paradigm is probably the better way to go. Yeah. So what is the other data that goes with the define? That's going to be like the module where the define happened. I mean, do we want to do the original, like we can do the original source code, the location in the file or in the module. Documentation. I don't think that the documentation should definitely go with the name and not with the object in the name. I think that makes sense. Maybe different spellings. Optimization information, maybe. Like compiler directives. Like where should the compiler directives go? Should they go on the binding? Because we just said that the variable object would be on there. Like the variable object would be the instance in there. So would the optimization information go on the variable? Because that doesn't make sense, because it's part of the runtime, sort of. So I guess you'd put optimization information on the binding itself. So closure solves, quote unquote, this. Let me see if I can. So if we go to closure, closure has this metadata thing. That's how they solve it. But I'm not sure if this can be applied to any arbitrary thing. Symbols and collections support metadata. Map of data about the symbol or collection. Collection. Why would collection support it? Is that so they can apply? Is they saying that an S expression is a collection and they can apply it to just anything? It is used to convey information to the compiler about types. Okay, so they are using it for their type system. So this is definitely to an object. So you can attach this metadata to any object. I don't know if I'm ready to go that far. But that may be what you would have to do. So it's only some kind of objects, though. Tagged literals, record type, and constructor calls. Because the once you associate the metadata with it, it's stuck to that object. Okay, well for now we'll just put the meta. We'll let the binding have some metadata. I think that's a good compromise. Because I don't think the meta system of attaching it to every object really works. And they're kind of vague about. I'm not sure what they're doing there, but it looks like they're able to attach it to any S expression. And I'm not sure if I'm ready to do that yet. So instead, we'll just let the binding have. I think this data is probably going to have to be public, but we'll see. But so the binding will be the binding between a name and an instance. So the first thing is it should probably have the name and the instance that we want to put on the binding. And so then we can probably make these inline functions too, and we'll make the private variables for them. So we'll make inline accessors for these for now. Instead of okay. And then we'll make a function to put the other things on there, like the module and stuff. I don't know if I should make them typed. I think for now we'll stay with the loose metadata, like the dynamically typed metadata. keep them dynamically typed for now. One of the things I want to do is standardize our things like keywords and symbols, and for that matter strings, so they all share a common stringify interface, so you can get the keys out here. Call this value. Okay, I think that looks good. And then this add meta function. So you can add metadata to symbols, I think is the better way to go here, instead of adding metadata to any arbitrary object. Optimizing arbitrary objects in the future may require you to put them in symbols. I don't think that's a very large burden for the time being. Especially because you're just saying put a let on them, and then you can attach your metadata to them. Like you put optimization data in here. I think that should be fine. I don't think that's going to be a big deal. Here, let me talk it over with my business partner. So.
You didn't mute.
I know I didn't mute.
Is that your intent?
Yes.
Like okay, what's up?
Well, so I ran into this thing where it's like I want to be able to attach a piece of metadata to a symbol so that I know where it came from. I want to be able to say what module it came from, so the file path of where it came from. And then also being able to do things like what line of code, what the original source code was, maybe documentation, right? But so then my problem was other Lisps, like Clojure, allow you to attach metadata to any arbitrary symbol or collection. And I thought about it for a moment, and then I went through their documentation, and so collection includes S expression. So literally you can just attach metadata to anything.
Okay.
Because they seem like, oh, it's only symbols and collections. And I'm like, S expressions are collections, so you could attach it to anything. So basically what they're saying is you can't attach it to a literal. That's all they're really saying.
Like you can't document a string literal?
Yeah. Because you use a string as the document, so you can't put strings on strings or any bullshit like that, is all they're really saying.
That's cool.
But so I guess what I was saying is if we're going to put optimization data in the metadata of these symbol bindings, a limitation of that would be that if you wanted to attach a compiler hint to something, you would have to put it in a variable.
Okay.
But if we keep variables lightweight, that shouldn't be a big deal. Especially because and see, it's not even a variable. You'd have to put it in a name. That's not necessarily a variable. Not all names have to be variables. You should be able to name temporary objects. So if for example, when you do in a block of code, if you say define foo and some expression, what you're really saying, you're not saying define a variable that I can set and get. It's kind of like you're saying define const, the result of this. So I don't think that's a big limitation for having to do that to be able to put metadata on that expression.
No.
Yeah, that's what I was thinking. It just means that if you wanted to have like add these two things, and multiply those two things, and you wanted to say this add use SIMD, this add use, I don't know, the video card or something, right? You wouldn't be able to do that. You'd have to say video card add, SIMD add, and then do the multiply as 3 steps instead of one expression. That would be the difference.
Okay. That sounds good.
Okay.
I'm going to go to the bank. Can you mute for a sec?
That's why he sits on your jacket, so you don't leave. Okay, so I discussed that with Clark, and he said that doesn't sound like too big of a limitation, so we're just going to do that. So here's our meta key equals the value. Great. So that's our metadata system for now. Well, first thing is this needs to actually be an object, and then we're going to need a get, I guess, as well. So get meta, and just we'll create an inline templated version of this just for convenience. It's going to tell me these can't differ only by return type, I bet. I bet you that's what it's going to say. And it's going to be right that that is a bad thing to be doing. But let's see if it gives it to me. If it does, I might change the name of one of these functions. I mean, or could not complain. That's nice. I was actually looking to do a soft as type because this is because I don't want it to crash if people try to get metadata of the wrong type off of there. I just wanted to say, nope, don't have that type of metadata. You know, out of luck. So I think what we'll do is actually kill 2 birds with 1 stone. We'll have this take a type ID. And if the type ID doesn't match the ID of the object in there, it'll just return null. And then we'll set this to the null type ID by default. Great. And then that'll fix our overload problem. So 2 birds, 1 stone. Great. doing some social networking in case anybody sees this. I'm just sitting here, not working on it. I seem to be experiencing some streaming thing, so give me a moment here. Trying to figure out what the streaming quality is here. Yeah, okay. Sorry, just screwing around with the bitrate here, since it seems to not like my bitrate. Okay, good. I think. Just doing more social networking. Social networking. Let's see if my local developer group has a channel for people who are streaming. Does not look like they do. Does not look like they do. Okay. Which I'm apparently now the top of watch people code or something. I don't know. Maybe it just picked me because I'm closest. Okay. Enough same shameless self-promotion on my local group to get some viewers. Let's get back to what I was working on. I actually have to implement this get meta function first. So we actually want to be able to get the value out of this binding for a symbol, get the metadata out there, and if it doesn't match this type, which we can move the default argument from here, doesn't match this type, then we want to return a null instance. So get our iterator from our meta dictionary. So we'll meta find the meta key. If the iterator equals the end, then we didn't find anything, right? So return a null instance. And then if it did find something, then we want to, if the instance, first is the key, second is the value. So if the type ID equals type, then we want to return it. Or if type equals null. If type equals types none, or so if they didn't ask for a specific type, or if it equals the type that we're searching for, then we want to return it. Else we also return null again. I think we could condense this to be a single expression, if expression, just because I am crazy like that. Put this on a new line because it's getting a little long. This is it does not equal. Great. So if the iterator is not at the end, that means we found something, and then if it's our anything type, or if it's the type we're looking for, then we return it, otherwise it's null pointer. Great. So that's our metadata for our binding objects. So now we can go to our namespace and I'm just going to close everything and reopen it. We can go to our modules and our scopes and change them so that they take bindings instead. And we're going to have to change the interface as well. So for my single new viewer, what I'm working on is adding modules and namespaces and scopes, or what I already had, to my Lisp bootstrapping system that's in C++. For a scripting language for an engine. Okay, so we're going to change this to fine to instead just take the binding that we want to add. And maybe we'll change the name of it later then. But So this will just take an instance of a binding, because the bindings have the names in them now, as well as the values and all the metadata. So we'll just have that be the interface now. So now we've got to go to our code that already existed and change all of that, which is the namespace, the module, and the scope. So this just takes the binding instance now. This is going to be instances of bindings. Module instances of bindings. Instances of bindings. Great. This one's already been done. Did I do? Okay. Go to the scope, change this. So now binding name equals binding. There we go. So that's our new define function that these three are going to share. I should really make this a base class, but I'm going to differentiate these pretty soon. These are going to get pretty different. So for now, I'm not doing a base class. So here we got to do something different, because on the second one, we actually want second value. Or do we? Or do we? Because, do we actually want the lookup to return the binding now? Because that's the actual on it. I think this is going to return the binding now. I think that's how this is going to go. So these return bindings now. Yep. These are going to return bindings. So this is not arrow value. So now our only problem is that everywhere we were using lookup, which I think is not very many places, everywhere we were using lookup is now going to be expecting. Yeah, so we're going to have to go look through those really quick. It's all Windows code. So this is a lookup function itself. Yeah, more or less. Whoa, what happened here? Oh, we now need to create a binding constructor for these. Yeah. Name value. That's what I thought. So I should just be able to do a like that. Except it doesn't like the standard string here. But I think we can fix that by getting rid of this. Well, I'm figuring out what's wrong with this. It's good. Is this good now? If I delete this? Nope. So I think what I'm actually going to do is make these all bindings. No, I'm not. That's a bad idea. But I will make all these bindings. Okay. I could find and replace this part, but I'm going to have to go back through all of these and put in the extra closing parenthesis. So here's a good example of one that I definitely want to make sure is right, because this is where we can actually add metadata. This is the actual define function itself. Okay, I'm glad that this library function is starting along. Yeah, I do plan to move a lot of this stuff into a Lisp, like boot up file, but it's going to be a little bit before we get there. Okay, great. So now if I build this, shouldn't have any problems there. I still need to go deal with the lookup. Okay, so this is not in the namespace. That's an easy fix. I think this one does, yes. Okay. Okay, so now we need to change scope because I've changed this signature of this. So we want to look up the symbol. We actually want the value off of it. The compiler's still going, so I'm not getting a telesense, but it should just be value. That should be the primary lookup function. I don't think I'm really using it anywhere else. Let's see. So this is the other one that, okay, so this is the loop. So the loop wants to look up its loop variable, and so I'm using this hack here. Oh, it's actually using it to look up the truth subroutine. Okay. Right. So if people redefine truth, then they can have their own truthiness in their loop. I don't know if that's the right way to do that, but let's see where else we're doing lookup here. Probably here as well. Great. So those are our loops. Oh, this is conditional. This is the loop. Okay. So let's get that building. That should be it, though. Where else do I call lookup? That's the function named lookup that does the lookup. Okay. Great. So now we can get the bindings out of our lookup. And so when we are now going to test our module, we should be able to call lookup on the resulting module and get the binding variable out of it, and then inspect the value of it once this is done compiling. This is not compiling. I think I accidentally hit rebuild, which I did not mean to do, because it rebuilt the type system. Okay, we should be good to go. So let's check the current working directory. Great. So now we're going to define our test module as the result of calling eval, file eval. Go up a folder, and I believe it's in tests, which is probably a little whatever. So I'm pretty sure that this error is actually coming from inside the module I'm evaluating, because define is definitely, like, define is there. So if I did a define, right, like I'm spelling it the same. Anyways, I mean that works, right? So it's definitely because the module itself has define in it, right? Oop, yeah, we should zoom that. So yeah, so the module itself has define in it, and I'm not propagating the global module that's in this console here to this module when I'm evaluating it. So we need to actually finish our namespace class so that it can access that information. So what we change now is we have bindings, so I can now put the module that I got the define from, the define that we're referencing, so I can look up what module it's from. So if I go to the globals, we'll do that first really quick. Where did I put it? It's down here, file, eval. Yes, so we're evaling this code. There's define in there. So this is going to be some sort of scope that we're going to have to set in the environment of what module we're currently reading from. And then we're going to have to get the parse state from the parser. So we'll do that one later, because that one's actually hard. We actually need the namespace to be working to be able to do this in the first place. So if we go to the environment, so this is where it makes the library of globals. So I need to now make a namespace. So we'll make a namespace. I could call it like the cult namespace, or maybe like the default namespace, because I want a user namespace and I want like the cult, like the system library namespace. So I think I'll call this one, I'll give them a prefix so I don't get too confused here. And we'll put the user namespace in here for now as well, but I don't think I'm going to use it that much. Okay. So now we're going to make those. So on startup, we'll create these two namespaces. So they take the environment, and then we need to import the module into this. So we have this module. So I think we need to add a function so that I can import this module. Something like import a module. And that should then be able to, because, well, so there's two ways I could approach this. I could approach this like most like Python or something, where I evaluate the module in the namespace and it modifies it. And that's how most Lisps would do it. So if I had two namespaces, right, I would switch to one namespace, I would evaluate the module in that namespace, and that would propagate all the symbols from that module into that namespace. If I wanted in a different namespace, I'd have to go to that namespace and reevaluate the module, unless you're using some sort of library system. Like, that's the way that it would do it in common Lisp. And I kind of like that, because then it's like each namespace is its own interpreter effectively. Alternatively, I could set up some sort of import so that I import after I've loaded the module, I could import the module in here and do and just like copy all the symbols, or do some sort of pseudo evaluation. I'm not sure. Does chat have any comments on that? Chat's not very lively today because there's not very many people in chat. So it's either I do this or I make library globals and I pass in the namespace, basically. Because one of the reasons for evaluating each module in the namespace separately is because the order of evaluation of the modules will matter. And this is something that people run into with Python code, where they have this code in there. They expect it to be ran when they import the module. But in our case, also, we have multi-methods, and so they need to be merged. And if you run them in different orders, I'm hoping that there won't be any order dependence there, but theoretically there could be, or at the very least with my exception system about when I throw the exception, because it's going to throw it when the conflict happens. So if you reorder the modules, you'll get the conflicts at different times. I mean, I guess it depends on whether I want import to be able to look at what I've defined and say, can those two things be merged? Because if there's like two multi-methods and I import the multi-methods from two different modules, I would need to write a merge method. But if I evaluate the module each time, then I could simply just keep calling attach. I think I am going to evaluate the module in each namespace separately. And another reason for that is because then the module will be able to look in the namespace and say what's already been loaded, right? It'll be able to say, oh, you've loaded this optional feature already, so that means that I can add my hooks for that optional feature. Which comes to like the dependency problems that a lot of modules face. Like I started like who's importing what module and importing them in the wrong order. Because then what you could do is you just start up a new namespace and import it in the right order. But that's like the opposite of like what Clojure does, because they have the Java library system and they're able to manage the dependencies. I think for now we will, because this would require me to write import features and like a merge function for the multi-method. But this one will basically say evaluate in the namespace like it's a brand new thing each time. So we'll do that. So since this code was originally written with an env, we'll extract that from the namespace. So I think modules are going to have a namespace that they're importing into. Yeah, I think that works. I mean, the module will be able to change what namespace it's in with like a macro anyways. So I think the module will have the namespace that it was meant to be imported into by default as part of its arguments. And it can get the environment from there, so we can simplify this expression. Because it'll have to be the same environment as the namespace. And then a way to get the namespace, just in case. Ooh, yeah, namespace is a reserved word. Namespace. There we go. Great. Fixed. Do that twice. Okay, so we'll go implement this code now, really quick. Okay, so the module now has the namespace that it's taking. Now we can go back to the globals, have our namespace, put that in the module. We have to go change the definition for the declaration of this function. Take a namespace. Great. I got to change the import order now. So I was going to do it the other way around, but I ended up doing it this way because I think this way works better. Let's see what we got here. Oh, need a namespace. Well, unless they provide us one, I think the correct namespace is going to be the one that this library was built with. I think that's the correct way to do that. Or actually what we could do is just check to see if these two are the same, and if they're not, then we can throw an exception. It's going to be a pointer check. So these pointers are the same, and they're two different things. Great. You know what? That actually really can't happen, so we'll just ignore that. That should never happen. If that happens, then we're way far off the deep end. It doesn't matter. Okay, so the module's got its namespace, and now we're able to eval into the module. And when the module gets to define, this is going to be the module, so it's going to go through here. So when the module gets defined, it's going to add itself to the scope of the binding. As a chunk of automatic code. So we want to capture that. Put that in our capture list. Great. Okay, so let's try this again. So let's try an eval. File eval. File eval. Zap a folder. Tests modules. Ooh, that's not good. So for some reason we got a bad copy constructor, it looks like. Or a destructor got called. So it's probably a bad temporary got copied into this environment. So let's look at this namespace. Does this namespace have an environment on it that's correct? It looks like it does. You know, this environment may not have been initialized correctly. So let's put a breakpoint here and try that again. So that's the first one. That's the second one. So it does have an environment. What's this environment? So that environment's null. Boop. It is. So swap, swap, turn this. Well, so this isn't good. This appears to be a compiler optimization. That's frustrating. I know what this is. Always what you get into for writing this code. Because this is uninitialized, but it should be initialized. According to this constructor, this should be initialized. And because I'm assigning into it here, it's like, oh, but it's not initialized. Well, that's frustrating. Is it an initialization order problem? Let's see what happens if we swap the order of this to match the initialization order. Okay. Time to fix it for realsies. I don't know why I have to fix this. It should be invoking the default constructor on these objects. Just because I'm assigning into it doesn't mean that it cannot invoke the default constructor on these. Great. Great. Yay! I invoked the default constructor. Like, It should be doing this automatically, and I don't know why it's not. Okay. Now I'm upset. Because see, this environment's not being set correctly, but here I'm definitely invoking the default constructor. Like that was the I don't so that's correct. That's exactly what it should be. No pointer, right? Get the environment from the namespace. And swaps, because it's an assignment. Those are both no pointers. Good, good. Great. Because this is, of course, isn't the one that has the problem. The one that has the problem is this one. That's a null pointer. That environment looks correct for the most part. No, it doesn't. Yeah, okay. So, no bugs there. It's definitely this thing here. That's the bug. Explicit capture matches default. Well, great. I don't know why that's an error, but sure. Okay, so that should fix that bug. Okay, so that's the same error. But it's because we still haven't finished doing the lookups. So when a module does a lookup, and it can't find the thing it's looking for, it needs to do a lookup in the parent scope. So we have a module now. If I reevaluate this, it's going to re-import it, but whatever. It should be fine for the time being. Okay, so now I should be able to call lookup on this. Got the binding back. No way to get the value off the binding at the moment. However, a few things I could do about that. Yeah, I think I'll write a separate function to do that. Okay, so let's go to globals. So we have our lookup function here somewhere. Here it is. So this is going to look up the value. Only if it's not null, though. Now we'll do a lookup meta function. Great. Two variants. Lookup. That was a mistype because I was talking to somebody else and something else. Anyways. Okay, so let's try this again. File eval, we'll put a fine in it. define test module as file eval.dat/tests/tests /module.cult. So, got our test module back. Look up test module foo. 15. Okay. We just got a value out of a module. Very fun. Okay, so that lookup's working. Let's try the lookup meta. Module. Ha! Got the module out. Okay. I think the first thing to do is to make it so those modules actually print their file names as their stringifiers. So, here's the module. Just to make my life easier, I'm going to go use an existing stringifier. Write it all out myself again. Defaults has to go last. Ugh, I screwed that up. To go change that to all the other ones. But whatever, not a big deal. Should probably add stringifiers for all of them as well. So this is going to be a module. Call it M. There's a file path on here. M file path. Just return the file path. I think that's fine. I kind of want to put it's a module, but nah. We'll just return the file path. I think it's the best thing to stringify it as. Okay, let's go put ones on the other ones. Anonymous scope is going to be hard to... The namespace should have a name that we can set it to, we can display. But let's see here. Good. I'm happy with that. So hey, that was evaluated in this namespace. If I say foo, so now that I've evaluated that, that's been put in the namespace that I was using. So if I go, so there's no way to get the current namespace at the moment. I think that's something I need to do. Right, something like that. Or like a context variable. I could also do a variant of lookup and lookup meta that doesn't take the starting module. I think having that should be the first thing. We'll do that one for now. No, the star one is more classic. We'll do the star one for now. Okay. So a namespace has call define on itself. Make a binding, call it ns, and then craft instance from this. Boom. So that'll give me ns. So what I should now be able to do, and this is going to be pretty magical, I think, is I should be able to do so if I do ns, get the namespace. So if I do file eval so get our test module, eval that. Have to put the extension on it. Okay, so now if I say foo, that was imported from the test module, right? If I do so, I should now be able to do a lookup on ns foo, get the value. That's not good. What happened there? Oh. Okay, well, that's a helper function I need to implement. I know what happened there. Okay, let's try that again. Eval my file. File eval /test /tests /module.cult. So this is our test module, right? So that imported. So now I should be able to access foo from that module. Great. I should now be able to do this little bit of magic. I should be able to do lookup the current namespace for foo. And then I actually want to look up meta. So look up meta, namespace foo, module, right? And that's the module where the foo variable is coming from. That's pretty cool. So I should be able to then put things like file, like line location and stuff in there as well. And so I can also do lookup, of course. So lookup in this namespace foo, and that's the or not. If I oh, because I made it a bare word, didn't like that, but it came in as a symbol. So I think it's about time I implement some helper functions so things like this don't happen. We're gonna add some safety to our global functions that we've been writing, because basically what we've been doing is just been doing a typecast here, and if the typecast fails, it throws a nasty exception like that. So really what we want to be able to do here is to say expect that this argument is this, expect that this argument is this, expect that this argument is this. And so these are actually symbols. So I'm going to implement some toString helper functions that I've been meaning to write for a little while. They're not really toString because there's a difference between like a display string and like a code string, because we have keywords and symbols and strings that are all kind of a lot of sections of the code should really treat those all exactly the same. And then we also need a helper function for saying I'm expecting a certain type here. So those are two helpers that we should write. the namespace for special forms. We're going to also make a namespace for library helpers. This is going to be the standard string. So we're going to just call this one symbol. And it's just going to take an instance. So this one, this is try to get a string from a symbol-like object. E.g. strings, symbols, and keywords. This will help with us like writing macros and stuff. Until we have the multi-method system. Until I have more implementations of multi-methods in the Lisp itself, like I need to write like the startup script. So until then, I'm gonna have to use this helper function to sort of get the strings out of symbols and stuff. And then the other one I'm gonna need is a templated function. So it's gonna have to be inline, which you can't have templated functions in code unless you specialize them. So this one is an inline instance T. And so I think this one's going to be like expect. So this way you give this an instance and you tell it what type name you're expecting. And it will either return that or throw an exception. So if the instance, if inst dot type ID equals, or we'll do, there is an is type on here, right? Yes, is type T, then return inst, then else throw an exception. So this will fix a lot of the bugs that we get in some of our built-ins about passing the wrong values in, because the built-ins are sort of designed to deal with any value. So this will help with that for now, until we can finish the multi-method system, and the multi-method evaluator can say, you didn't pass the right arguments. So you just want to say, standard exception. We can do like a formatted sort of saying, expected this, got this. So we'll put, we want type T, so we're going to have to do the type ID. So types, type T, type ID, expected that, got an inst, and we'll just let that print. Or we should really get the type ID of it. Yeah, so inst type ID. And then if inst is null, we want to throw a different exception. Or actually, I think if inst is null, we should just return inst as null. If not inst. There we go. So null values will stay null, but we'll throw exceptions if we're past the wrong type. So you still have to do null checking, but now we'll use this macro to deal with exceptions of the wrong type. So we'll go here. We'll use our new helper namespace. Craft Lisp library helpers. I think it was just helper. And so then we'll just do the lookup ones for now, the ones we've been working with. So now we should just be able to do yeah, auto. Well, that's a trickier one. We'll do that one later. And those are the strings that I wanted to be able to cast, but we can at least do these ones for now. So auto lookup name equals expect standard string args1 string. All right, this is equals, forgot the equal sign. We're saying we're expecting a standard string, and then this next one is lookup meta arg2. And then that should stop a repeat of what I just did. So let's try that again. Take a minute to compile here. So what I've been working on is this module system. And so these are the lookup helper functions. So I want to try to write like this boot script that implements all these functions, but these are the functions I need to be able to write the script in the first place. So this is sort of the bootstrapping step where I'm writing the Lisp in C++. So I'm writing the interpreter. So I had a compile error here. So this is a formatting error. I know what that problem is. So what happened here is I did the formatting here incorrectly, because this gives me the type, but I need to call toString on it because the formatter is not quite smart enough to be able to call that itself. Now, which file caused that? So I can check if this error is still global, which is what I thought it would be. So we'll try compiling that and see if that fixes it. Okay, it did. So that should fix the problem. So I'm just writing some, so I have this working now. I'm just writing some helper functions to get this Okay, so let's try this again. File, eval. Should really add that feature. So foo. So now if I do a lookup in the current namespace, foo. So yeah, that's not very explanatory, but it's pretty close. So it expected a standard string and it got an integer. And I'm like, oh, I forgot to quote foo. It's going to say, it's expected keyword. Good. Got a keyword. So there we go. Now that works. Now the next thing I want to do is I actually do want this to be able to take a keyword. I want this to be able to take a keyword. I want this to be able to take foo. And I want this to be able to take like a quoted symbol. I wonder if we actually have quoting working right now. I don't think we do. We don't. But that one should be pretty simple to do. So we can do that next really quick. But yeah, so we'll write the helper right now though. So we go to libraries. Where is this helper implemented? That's just at the top here. Great. Special helper symbol. Lisp library helper. We'll call this one the library helper. Symbol. Return standard string. It takes an instance. And so its job is to just get the string that we're trying to represent with the symbol here out. So really, this is just a little bit of it's just a bit of like virtual dispatch, which we implement in other places. But so like this right here is what I'm trying to avoid. I think this section is the one we want, and then else throw an exception. So if the type is a symbol, if the type is a keyword, if the type is a string, and then we want to return, else, throw standard exception. So the given cannot be used as a symbol. Okay, so that should allow this function to take symbols, keywords, standard strings. The only thing now is we actually need a way to pass a symbol in, but we'll get there. And so here now, wherever we were using string before, we actually would use the symbol one. So here also actually we want to be using expect, just in case. So we'll do that really quick to fix up these math ones. Just because this is... Don't want those breaking. So here, instead of using expect now, we can use symbol. Symbol. Here. And I'll see if there's any others that would benefit from using this. I mean, there's a place I actually copied that whole dispatch from that would probably... Yeah, right here. What is this? This is define, right? Yeah, I don't know if I actually like this one. So this one, this is defined. So name value. I mean, this whole... Okay, so this does the eval. So symbol, keyword. So actually what we want to do is we want to see if it's... We want to do a try, basically. We want to try catch this. So we'll do a try. So bool got name. No, we don't want to try catch this because if we evaluate the name, no, this is defined, right? Well, how about we do if it's code, we'll execute it, and if it's not, then we won't. So that's how we'll do this. So if the name is, so we don't need the try block. Equals symbol of the name. Great. So here we assign the name value is the symbol of the name. That's what we want. We don't need this got name thing I was about to do anymore. So this is the name. So if the name dot type ID dot is type this expression. Okay, we'll evaluate that. We'll evaluate the name if it's executable, if it's an X expression. Else, then the name value is just the symbol of the name. Great. That's better. I don't think any of these other ones use. Craft type does. If it's a keyword, right here. So lookup equals, what was that, arg0? Arg? Yeah. So what we really want from this is great. So now we have our symbol casting for all these functions. I ran into a bunch of errors for some reason. This looks to be some sort of cascading thing. I think oh, so I don't need to dereference this anymore. That's probably what broke everything. So we've replaced all of our references. There we go. Much better. So let's see what's going on here. It's that again. So now that we've replaced all of our incoming arguments with the symbol function, we should get a lot less exceptions when we're trying to define things or use different modules. We just have to change all of our usage of the lookups of them. Okay, now we're down to much fewer. I misspelled the word int here, so that's why this code is not working. So this is the expect macro that we wrote, which will make sure that the arguments are the expected value. Okay, so now our built-in functions won't crash with segfaults when we call them, which is always nice. So now I should be able to define, I don't really have any string functions right now, so we can't really test that one. But now if I do an add of foo and a 5, okay, expected an integer got a string, file eval tests module.galt. Boom. Okay, so now I can do foo, and now I can do lookup, current namespace, foo. So that's a type error now, which is correct because we're trying to pass an integer in there, which is not what we want to do. We can now pass in foo, and we can pass in foo. And if I had the quote working, we could pass in foo. So if I get the quote working, we could also do that. So all three of those are the same effect, basically. I also like foo module, so that looks nice. That's what I want, really. Really, actually, what I want is this, right? Look up in this namespace, the quoted foo, get me the module keyword. But it's nice that effectively this function works with any variation of symbol. So if you're writing a macro, you don't have to worry too much about whether the variation of the symbol that you have is a quoted symbol, or if it's a keyword, or if it's a string. So I mean, they just all work the same. So that'll be nice when we get to macro writing. Okie dokie. So that's some serious changes that we've made. I'm just trying to think if there's anything else that could go along in this sort of update. Let's see how hard it would be to add quote really quick. I think it would be pretty easy. We would need to make a quote object, though. Yeah, S expression here. Well, I think what we have for now is a good commit. So let's write the commit. So we added the sScope interface for scopes, and we had it subclass from the scope namespace and module. We also, I think what's notable about that, though, besides what classes we had inherit from, is that we changed the calling. We changed p subroutine to use this scope rather than the other one. So I think that's the more notable part. We didn't really change any of the evaluator. We're adding to the environment some default namespaces. And we're adding some features to the global library. And eval file now makes a new module. Making file evaluation, create modules in the current namespace. Well, we should probably change that, but we can do this some other time. So, the reason I was doing all this is for the creation of our new game that we're working on. So I think I'm going to swap over to developing that now that I have the features in here that I need. Although I should add one more feature to this, which is multiplication, since we don't have that. And on the list of things that are difficult to make, that is not on it. So we'll do that really quick. Boom, multiplication added. That was easy. Let's just test it really quick. You know, can't ever be too safe. Great. Cool. So I'm going to take a quick break, and then I'm going to restart the stream. Not that anybody who's going to see this is going to care about that. So there's nobody else watching. But yeah, I'm going to commit that really quick. Okay, 1 second. I'm ending the stream. Okay, I will be back in a little bit.